Everyone, this is a new video series, lecture series in which we'll be discussing questions from previous year NEET questions. Okay, so these are NEET Physics PYQs. There's a new series I'm starting today, and we will continue it till our NEET exam. Alright, so this series will help you prepare for NEET exam. We'll be solving questions from all chapters. Okay, today we'll start with a chapter from which many questions come. That is your waves. Okay, waves is a very important chapter for your NEET exam. So I'll be solving the questions. Okay, and yeah, let's start. So first question, I would urge you to solve along with me as we're writing the questions. The displacement of a traveling wave, the displacement of a traveling wave. Okay, traveling wave is y is equal to c. Okay, sine 2 pi by lambda, right? At minus x, where t is time, okay, x is distance, lambda is the wavelength, right? All in SI units. Then the frequency of the wave is in the frequency, and simply the frequency of the wave. Frequency of the wave is, okay. Options are option A 2 n pi, so 2 pi lambda 2 pi lambda by a. Option B 2 pi a by lambda. Option C lambda by a, and option D a by lambda. So this is the question. You have 2 minutes to solve this question. You have to solve as fast as you can. One, okay. You have 1 minute 30 seconds. Okay. So yeah, try. Okay. See if you have solved it or not. I'll just. It's very easy question. Okay. So, y is equal to c sine 2 pi by lambda at minus x. Okay. So if I multiply this inside, so c sine 2 pi by lambda at minus 2 pi by lambda into x. Okay. So we know the wave equation. We know wave equation is how much? Y is equal to a sine kx minus omega t, right? Kx minus omega t. So if I compare this with this, so this is omega t minus kx. Omega t minus kx. Okay. So omega will be 2 pi by lambda a and k will be 2 pi by lambda. We know k is equal to 2 pi by lambda. So this is omega can be written as k into a, right? So omega is ka. So frequency will be how much? Frequency is 2 pi, what, omega by 2 pi, because it's omega by 2 pi. So ka by 2 pi, right? Ka by 2 pi. So now k by 2 pi, again I can write it as a by 2 pi whole divided by k, right? Because why? Because 2 pi by lambda is equal to k. So 2 pi by k is equal to lambda, right? So I can put in place of 2 pi by k as lambda, okay? So a by lambda will be your answer. This is your frequency. So frequency is a by lambda. So this is the answer, a by lambda. Option D will be the correct answer. Option D will be the correct answer. Yeah, okay. All right. Question number 2. Question number 2. Two slits in Young's double slit experiment YDSC. Okay, this question came in NEET 2024, so it's only previous year. Okay, two slits in YDSC are 1.5 millimeter apart, 1.5 millimeter apart, and and the screen is placed at a distance. Screen is placed at a distance of 1 meter from the slits. 1 meter from the slits. All right. So, if the wavelength of the light, if the wavelength of the light, if the wavelength of the light used is 600 nanometer, then the the fringe separation is, okay. So options are option A, 4 into 10 to the minus 4 into 10 to the minus 5 meter. Option B, 9 into 10 to the minus 8 meter. Option C, 4 into 10 to the minus 7 meter. And option D, 4 into 10 to the minus 4 meter. So this is again, it came in NEET 2024. Okay. So try, I'm giving you 1 minute. This is an easy question. So even 1 minute is a long time. This 30 seconds you should be able to solve this question. Within 30 seconds. You have 30 seconds. Two slits in YDAC are 1.5 millimeter apart, and the screen is placed at distance 1 meter. Direct formula. Okay, so I'll be solving a very easy question. I hope you have solved it. If you haven't, you just try. So fringe separation, direct formula. Fringe separation beta is equal to lambda capital D by small d. We know it, right? Yeah. In lambda capital D by small d. Okay, so beta is equal to lambda is how much? 600 nanometer. That means 600 into 10 to the power minus 9. Okay, capital D is the distance between what? The slits and the screen. This is capital D. Yeah. So how much is it? This is 1 meter divided by small d is how much? So placed, okay, 1.5 millimeter apart. Then small d is the between the slits. So 1.5 millimeter. That means 1.5 and 10 to the minus 3. Okay. So this 10 to the minus 6, and this is 15. This becomes 6,000. So it's 400. Okay. So 400 into 10 to, you have to fasten your calculations. Okay. So this is 4 into 10 to the minus 4 meter. So which will be which option again? Option D. Okay. Option D will be the correct answer. It's kind of a mixture of optics also. Yep. Optics is also coming in this chapter of waves. Okay. Easy question, easy pickings. Okay. Don't leave this in exam. Option question number three. Question number three. Interference pattern. Interference pattern can be observed. Can be observed due to superposition of the due to superposition of the following waves. Superposition of the following waves. Okay. Option A, y is equal to a sine omega t. Option B, y is equal to a sine 2 omega t. Option C, y is equal to a sine omega t minus phi. Okay. Option D, y is equal to a sine 3 omega t. Okay. So which of the following interference will be pattern can be observed due to superposition of following waves? So choose the, okay, sorry, choose the choose the correct answer from the given below, from the options given below. Okay. So what are the options? Option A is B and C. Okay, I will just wait. Option B is B and D. Option C is A and C. And option D is A and B. The question, what is the meaning of the question? The meaning of the question is interference pattern can be observed due to superposition of which waves? Okay. It's not like interference will happen everywhere. it, Interference has some conditions, right? So which two waves satisfy those conditions, and due to whom the interference will occur, right? So yeah, try. You have 30 seconds again. I'll only give you 30 seconds for it. Interference pattern can be observed due to superposition of the following waves. Okay. So y is equal to a sine omega t, y is equal to a sine 2 omega t. C, option C, y is equal to a sine omega t minus phi. And option D, y is equal to a sine 3 omega t. Okay, so you have to choose the correct answer from the options. Okay, first of all, okay, let's do it. How to solve it? See, the condition of interference. What is the main condition of interference? Main condition of the interference is this, like the what? The sources must be coherent. Okay, so the sources must be coherent. That is the main condition of interference. Okay, so coherent, how would I know which where the sources are coherent? Okay, just see, coherent means again what? Frequency should be same, right? So where the frequency is same. See, here is omega. Frequency is nu is equal to omega by 2 pi, right? So see, omega, this is here, this is 2 omega, so they won't match. This is 3 omega, they won't match. So this is omega, so they are matching. So option A and C are matching with each other because they have the same frequency. Coherent means same frequency also. So A sin omega t, option A, and option C, y is equal to A sin omega t minus phi. Okay, so these two options match with each other because they are coherent, they have the same frequency. So because of them, interference will occur. Okay, yeah, all right. Yeah, again a good question. This question came again in previous year only, NEET 2024. Okay. So next question, question number four. Question number four. The ratio of frequencies, the ratio of frequencies of fundamental harmonic fundamental harmonic produced by an open produced by an open pipe to that of closed pipe, that of closed pipe having the having the same length is, okay, the ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe having the same length is, okay, option A is 2 is to 1, option B 1 is to 3, option C 3 is to 1, and option D is 1 is to 2. So this question came in 2023 NEET. Okay, so yeah, try. I'm trying to solve questions of every year from this chapter. Okay, so yeah, please try. So ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe having the same length is, ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe. So for that you need to know the concept of it or remember the formulas. See, I will do it. I hope you have solved it. If you haven't, see, open pipe. Okay, frequency of open pipe, FO. Frequency of open pipe is okay, V by 2I, right? And frequency of V by 2L, sorry, it's 2L, okay? V by 2L. Frequency of this one, closed pipe FC, F closed is equal to V by 4L. Okay, please remember this too. This open pipe is 2L, V by 2L, closed pipe is V by 4L. So, what is the question? Ratio of open to that of closed. So, F naught divided by F C. So, V by 2L divided by V by, I'm writing a small v, okay? This is not new, this is small v. So, this is 4 is to 2, that is 2 is to 1. Okay, so the answer is 2 is to 1. For this, you need to remember the formula of open pipe and closed pipe. So, if open pipe is equal to V by 2L, if closed pipe is V by 4L. Alright. Yeah. Alright. Question number 5. The fourth overtone, the fourth overtone of a closed organ pipe is same as that of that of third overtone, same as that of third overtone of an open pipe. Okay. Fourth overtone of a closed pipe is same as that of third overtone of an open pipe. Okay. The ratio of the ratio of the length the ratio of the length of the closed pipe length of the closed pipe to the length of the open pipe is length of the open pipe is okay. This came in NEET 2023. Okay, the fourth overtone of a closed organ pipe is same as that of third overtone of an open pipe. The ratio of the length of closed pipe to the length of the open pipe is option A. Option A is 8 is to 9. Option B 9 is to 7. Option C 9 is to 8. And option D 7 is to 9. Okay. Fourth overtone of a closed organ pipe is same as that of third overtone of an open pipe. So yeah, you have 1 minute to solve this question. It should not take more than 1 minute in a question. Okay, that should be a strategy in your NEET exam. 60 questions. So yeah, okay. See, the concept is okay, frequency of frequency of closed pipe. Okay, closed pipe is equal to 2m plus 1th harmonic. Okay, so see what is the m here? What is the closed pipe? M. What is M? M means number like the which th, fourth, third. So four. So okay, harmonic. All right. That means it's like 2 point. Okay, the question formula will be 2m plus 1 into v by. Okay, what is the frequency for closed pipe? See, v by 4l. So v by 4l. All right. So 2m plus 1, 2 into 4, fourth. So 2m into 4 plus 1 into V by 4L, right? So, and this is L closed. Okay, this is closed. So this is 9. So 9B by 4L closed. Okay, now the same as that of third overtone of open pipe. Okay, third open pipe FOP. Open pipe is M plus 1 into, remember, M plus 1 harmonic. Okay, that means M plus 1 into, and what is the frequency for open pipe? We just do V by 2L. Okay, so V by 2L, and this is open, so VL not O. Okay, and this is third overtone, right? So 3, M is 3, so 3 plus 1 V by 2L not. This is 4 by 2 2 2 V by L not. Okay, but it's also in the question Both of them are same, right? Fourth over 10 is equal to third over 10 of an open. So we can write 9v by 4lc. 9v by 4lc is equal to 2v by l norm, right? So v cancelled out. Okay, v cancelled out. What is the question? Question is a ratio of length of close to open. So LC by LO. So LC by LO is equal to LC comes to this side, 2 goes to 9 by 8. Right? So the answer will be 9 is to 8. Got it? Again, you need to remember these two formulas here. Yeah, two formulas you have to remember. Alright. Okay, next question number 6. Question number 6. If the initial tension, if the initial, if the initial tension on a stretch, on a stretched string, initial tension on a stretched string is doubled, then the ratio of, then the ratio of, then the ratio of the initial and final speeds, then the ratio of the initial and final speeds, ratio of the initial and final speeds of a transverse wave along transverse wave along the string is, transverse wave along the string is dash. Okay, this came in NEET 2022. Okay, so option A 1 is to 1, option B root 2 is to 1, option C 1 is to root 2, option D 1 is to 2. If the initial tension in the stretched string is doubled, then the ratio of the initial and final speeds of a transverse wave along the string is. Okay, so we have 30 seconds to solve this question only. Okay, so first of all, velocity speed of final initial and final speeds of transverse wave. So first of all, we need to know what is the speed of a transverse wave. So velocity of a transverse wave. Okay, so how much is it? V is equal to root over of T by mu. Okay, T by mu is the mass. So V1 by V2. Okay, because it is initial by final. So V1 is suppose initial, V2 is final. Okay, stretch it is string is doubled. That means if you see the string is single string, that means the mass is same, only the tension is being doubled. So root over of T1 by T2, right? So T2 is double, T1 is double becomes T2. So T1 by 2T1, right? Because T2 is double of the like this, twice of the first one. So it becomes 1 by root 2, right? So V1 by V2 is equal to 1 by root 2. Again, very easy question, 1 by root 2. These questions are coming in exam, so you should be able to solve them. Okay, next question number 7. Question number 7 again. Again an organ pipe question. An organ pipe, an organ pipe filled, an organ pipe filled with a gas, organ pipe filled with a gas at 27 degrees Celsius. Okay, resonates at 400 hertz. Okay, in its 400 hertz in its fundamental mode. Fundamental mode. Alright. If it is filled with, if it is filled, if it is filled with the same gas, if it is filled with the same gas at 90 degrees Celsius, okay, the resonance frequency, the resonance frequency at the same resonance frequency at the same mode will be, resonance frequency of the same mode will be dash. Okay, so this is NEET. This also came in NEET 2022. Okay, so your options are 512 hertz, option B 420 hertz, option C 440 hertz, and option D 484 hertz. Okay, so yeah, try. An organ pipe filled with a gas at 27 degrees Celsius resonates at 400 hertz in its fundamental mode. If it is filled with the same gas at 90 degrees Celsius, the resonance frequency at the same mode will be. This is the first temperature, resonates at 400 hertz. So try to find the like yeah the relation between temperature and frequency, because these two things are only there. Okay, so you have 30 seconds in an easy question. So 30 seconds is maximum you can take for this. Okay. So see, it's a very easy question again. Frequency, frequency F is equal to V by lambda, you know, and velocity of sound. Okay, velocity of sound we know is proportional to root over of t. Right. So eventually, frequency is proportional to root t, where t is the temperature. Okay, not the time period. T is the temperature. So F1 by F2 will be equal to T1 by T2 root over. Right. Yeah. So what is the first frequency? First frequency is 400, and temperature we have to convert it into Kelvin. Okay, F2 is equal to, temperature is Kelvin, 27 is 300 Kelvin, and 90 is 363. 300 by 363, right? Yeah. All right. Okay. So how do we do it now? Suppose we cancel to the 100. So 100 divided by 121, right? Okay. So root over, if we take, this is 10 by 11. Very simple. F1 is how much? F1 is given as 400 hertz. Okay. So 400 by F2 is equal to 10 by 11. F2 is equal to 4400 by 10. So this is 440 hertz. Okay. Again, easy question. Just need to know the relations. Okay. Important relation from here. F is proportional to root T. So this is 440 hertz. Answer is 440 as option C. Okay. Question number 8. came in 22. Next question number 8. In a guitar, in a guitar, two strings A and B, two strings A and B, made of same material, same made of same material, okay, are slightly out, are slightly out of tune and slightly out of tune produce produce beats of frequency, produce beats of frequency, beats of frequency 6 hertz. Okay, all right. When tension in B, when tension, when tension in B is when tension in B is slightly decreased, tension in B is slightly decreased. Okay, the beat frequency, the beat frequency, the beat frequency increases to 7 hertz. Okay, 7 hertz. Okay, if the frequency of A, if the frequency of A, if the frequency of A is 530 hertz, frequency of A is 530 hertz, the original frequency of B will be, the original frequency, the original frequency of B will be, big question, but it's a very easy again. B will be what? So option A 524 hertz, option B 536 hertz, option C 537 hertz, and option D 523 hertz. This came in NEET 2022 20 sorry 20. Okay, in a guitar, two strings, okay, two strings A and B made of same material are slightly out of tune, produce beats of frequency 6 hertz. When tension B is slightly decreased, the beat frequency increases 7 hertz. So again, you need to find the relation between tension and frequency. Okay, tension and frequency. All right, I'm giving you 30 seconds again. Solve this. Let's try. All right. So frequency of string, the formula is frequency of string f is equal to, okay, 1 by 2l root over of t by m, correct, where t is your tension. All right, t is your tension. So if you see, so frequency is directly proportional to root over of tension. Okay, all right. So okay, now the question is, um, made okay out of tune and produce beats of frequency. So that means the difference between, okay, they're out of tune and produce beats of frequency 6 hertz. That means um, their difference is 6 hertz. Okay, in the FA minus FB, because they're out of tune and there is a slight difference, that is your 6 hertz, not individual. When B is slightly decreased, beat frequency increases to 7 hertz. Okay, now FA minus FB is now 7. Okay, suppose this is dash or something like that. This is 7 hertz. So frequency of A is this, original frequency of B will. Okay, so how do you do it? How do you do it? Okay, original frequency of A is Fa is equal to 530, and tension in B is slightly decreased. So tension in B is slightly decreased. If tension in B is decreased, then its frequency will also decrease, right? And frequency will also decrease. All right. Yeah. Another thing, see, Fa minus Fb is 6 Hz. All right. Now it is increased to 7 Hz. So the difference has increased to 7 Hz. So Fa minus Fb is 7 Hz. That means Fa is greater than Fb, right? Fa is greater than Fb. All right. Yeah. So if Fa is greater than Fb, then tension of A should also be greater than tension of B, right? Yeah. All right. So tension of A is 530. So what should be the tension of B? What should be the tension of B? What should be? Because 530 and the difference was 6. So it should be 524. Simple. Very simple question. Alright. The original frequency is asked because, okay, if we forget everything about this question, the difference is 6. Frequency of A is 530. So the other one will be 524. The 530 minus 524 is 6. Okay, very easy question. It's just so much is there, but the trick is here. Alright, original frequency, yeah, that's why it will be 524. If suppose it was written, if A frequency of A is now 530, what is the next new frequency of B after it has increased? That will be 523. Okay, yeah, alright, okay. So right now write a homework question number 10. This is a homework for you. Question number 10. A tuning fork, a tuning fork with frequency of 800 hertz produces produces resonance resonance in a resonance column tube, in a resonance column tube with upper end open and lower end lower end closed by water water surface. Okay, successive resonance successive resonance are observed successive resonance are observed at length 9.75 centimeter, 31.25 centimeter, okay, and 52.75 centimeter. The speed of sound in air, the speed of sound in air is, okay. This came in NEET 2019. Okay, so options are 500 meter per second, option B 156 meter per second, option C 344 meter per second, and option D 172 meter per second. Okay, so yeah, try this question. This is a homework. All right. So these are some PYQs we did today from waves, and we will continue. Okay. Well, I will do a lecture every day up to your NEET exam. So yeah, stay tuned to the channel. Okay. Yeah. Thank you.